Hey scholars, I hope this video finds you well. So far we've talked about how to add, subtract, and multiply polynomials, and today we're going to talk about how to divide them. It may seem a little tricky at first, but you can definitely get it. Just make sure you pay close attention and take good notes. Let's get started. So before we talk about long division of polynomials, let's talk about regular long division of just regular numbers. So for this problem, we've got 88 divided by 7. So we're going to see how many times does 7 go into 88? Well, first we got to ask ourselves, how many times does 7 go into 8? Well, it goes into 8 one time. So we're just going to put that above the first 8. And then 7 times 1 is just 7. So what we're going to do, as you may recall, is that we're going to subtract 7 from that first 8. 8 minus 7 is 1. So then what do we do next? We look at that next 8, right? And then we're going to drop that down. We're going to drop down the 8. And then how many times does 7 go into 18? Well, it goes to 18 2 times. So we're going to put that 2 next. And then 7 times 2 is 14. So we're going to subtract 14. And then remember, the remainder is 4. So when you first saw this, you would probably have written the answer as 12, remainder 4, maybe in like 3rd or 4th grade. But as you got older, you learned that you could write this as 12 and then a fraction. 4 is the remainder, right? 4, and then the divisor is 7, so we put that divisor in the denominator of the fraction. So 12 and 4/7 is a mixed number that is the answer to 88 divided by 7. And that is the same methodology we're going to apply when we're dividing polynomials. So here are a couple examples that you'll see on your slides, which you should already have out. You can see a couple examples of how to perform polynomial long division. So I encourage you to look at those, and I'm just going to make sense of how to solve those problems on these next slides. Alright, so let's try this. This problem says to divide x squared plus x minus 42 by x plus 3. So let's set this up like that example we just looked at, where we kind of have the house, and we have the divisor on the outside of the house, and then we have the dividend underneath the house. So we have x squared plus x minus 42. So we're saying x squared plus x minus 42 divided by x plus 3. X plus 3 is what we're dividing this by. So here's what I'm going to do first. I'm going to look at x, and I'm going to ask myself, how many times does x go into x squared? Don't worry about the plus 3 yet. We're just going to say, how many times does x go into x squared? Another way you could think about this is to say, what times x gives us x squared? What times x gives us x squared? Well, it's x. X times x is x squared. So I'm going to put that up here. So x is going to go above the house. X times x is x squared. So remember how in that first example I said that 7 goes into 8 one time, and then I put 1 up at the top. Well, 7 times 1 is 7, and then we said 8 minus 7. So here's what we're going to do here. We're going to say x times x is x squared, but then we're going to subtract x squared. So I'm going to say minus x squared. Again, x times x is x squared, so we're subtracting x squared. Now, here's where that plus 3 comes in. We're going to take that plus 3 and say 3 times x is 3x. So 3 times x is positive 3x, but I'm going to subtract that as well. If it's plus 3x, positive 3x, I'm going to change that to minus 3x. If you need to rewatch that, make sure you do. Rewind that and see how I got negative x squared minus 3x. So what's going to happen here is x squared minus x squared, well, that's going to cancel out, right? And then we have x, positive x minus 3x, well, that's negative 2x. So we're left with negative 2x right there. And then what I'm going to do is I'm going to drop down to negative 42. So negative 2x minus 42. And then I just start this process over again. I ask, what do I multiply x by to get negative 2x? What times x is negative 2x? Well, that's negative 2. Negative 2 times x is negative 2x. So I'm going to put negative 2 right there at the top. And then I'm going to say x times negative 2. Well, x times negative 2 is negative 2x. But I'm going to change the sign there. X times negative 2 is negative 2x. I'm going to change that to positive 2x. I'm going to add 2x. Because the goal here really is to just cancel out that term right there. See how we canceled out the x squareds earlier? Well, now we're trying to cancel out the negative 2x by adding 2x. And that happens when we multiply x times negative 2, and then we change the sign. So now I'm going to do the same thing with 3. I'm going to say 3 times negative 2. Well, 3 times negative 2 is negative 6. But again, I'm going to change the sign. It's going to go from negative 6 to positive 6. So I'm going to add 6. So negative 42 plus 6, that's negative 36. So this is our remainder. I'm going to circle this. That's the remainder. So I'm going to write my final answer as x minus 2. And then we can say plus negative 36, the remainder, right? Negative 36 over x plus 3. We can say that is our final answer. Another way of writing this would be to say x minus 2, and that's a plus negative, right? Plus a negative is just going to give you a negative. Well, then we can say minus, and then positive 36 in the numerator over x plus 3. And there we go. There's our final answer. So, two different ways of writing the same answer. Let's look at one more example of this. All right, next we want to divide 3x cubed plus x squared plus 4x minus 5 by 3x minus 2. This one might be a tiny bit more complicated, but we're still doing the same exact algorithm that we did in the last problem. So 3x minus 2 is going to go outside the house, and then under the house, 3x cubed plus x squared plus 4x minus 5. All right, so think, what are we going to ask ourselves? Well, what times 3x is 3x cubed? 3x times what is 3x cubed? Think about it. Oh, it's x squared. All right, so I'm going to write x squared up here. So 3x times x squared, that is positive 3x cubed. But remember, we're going to change that sign from positive to negative. So I'm going to say negative 3x cubed. And then we're going to look at the negative 2. Negative 2 times x squared. Well, that's negative 2x squared. Change the sign of negative 2x squared, you get positive 2x squared. We're adding 2x squared. So, now this will cancel out. Then we're going to say x squared plus 2x squared. That's 3x squared. And then we're going to drop down this next term, plus 4x. All right. And then we're going to start that process over again. What do you multiply 3x by to get 3x squared? That's x. Good. All right. 3x times x is 3x squared. So then we're going to change the sign. 3x times x is 3x squared, so we're going to change it to negative 3x squared. And then we're going to say negative 2. We're looking at the negative 2 now. Negative 2 times x. That's negative 2x. But we've got to change that sign as well. Negative 2x will change to positive 2x. So that'll cancel out. 4x plus 2x is 6x. And then I'm going to drop down the minus 5. We're almost done. What are you going to ask yourself? 3x times what is 6x? 3x times 2. 3x times 2 is 6x. But remember, we're going to change the sign. We're subtracting 6x. And then we got to look at the negative 2. Negative 2 times positive 2 is negative 4. Well, then we're going to change that to plus 4. 6x minus 6x. That'll cancel. Negative 5 plus 4 is a negative 1. So there's our remainder. We have nothing else to drop down. There's our remainder. So our final answer is x squared plus x plus 2. And then that's a negative 1 as our remainder. We can say minus 1 over, and we look right here, right? That's going to be our denominator, 1 over 3x minus 2. And there we go. Like I said earlier, you can also rewrite that as x squared plus x plus 2 plus negative 1 over 3x minus 2. That also works. Okay? So I know there were a few steps to try to keep up with and try to get down, but I think the more you practice with it, the more it'll click with you. So if you need to even rewatch parts of this video to be ready for class tomorrow, I encourage you to do so. But come to class tomorrow prepared to work and with questions. Good work today. Thank you, Collegiate Scholars.